Hello, I'm Walid Al-Awali, and today we're going to talk about vector-borne diseases and environmental changes. Vector-borne diseases are already being affected by climate change, and the effects are expected to worsen in the future. Vector-borne illness control must be stepped up in light of the current state of climate change. Anthropogenic greenhouse gas emissions are speeding up Earth warming, which will have long-term consequences for vector-borne disease prevention and management. In a nutshell, vectors, which are cold-blooded creatures, thrive in warmer climates. Other non-climate factors contribute to the spread of vector-borne diseases, which makes it impossible to pinpoint climate change as the only cause. Mosquitoes are the most prevalent, the most well-known pest, but isn't the only one. We have sandflies, fleas, ticks, and houseflies, which are all responsible for spreading vector-borne diseases. Fleas caused so much destruction in the early days because of trade routes from Eastern Asia to Europe that they almost wiped out a nation.
Wow!
17.5% of all infectious illnesses are caused by major vector-borne diseases. There have been many outbreaks of mosquito-borne diseases since 2014, including Zika, dengue fever, and malaria. Many factors influence the spread of malaria, including air temperature and humidity. Areas with a tropical environment are more likely to have vector-borne illnesses. Both Lyme disease in the United States and malaria in Africa may be traced back to the equator of our planet. It's not clear what will happen if the temperature rises. The more crucial question is, what happens when global temperatures rise to the point that these insects may now use their living microsystems to move to other regions? Now we'll look at technical and scientific techniques to deal with vector-borne diseases. It is possible to predict disease incidence and transmission using a process-based or empirical vector-borne illness model in conjunction with future climate change scenarios based on predicted greenhouse gas emissions. Assume that the temperature changes but that the other non-climate characteristics do not change. A long-term steering strategy may find utility in this information. Global climate models (GCMs) forecast future temperature, precipitation, and humidity based on historical data relative climate change. It is envisaged that an ensemble of generalized linear models (GCMs) would be used to analyze model uncertainty. An illness model for vector-borne diseases might be developed utilizing the information provided by the study. It was decided to develop historical geographic spread models for the Egypti and Albopictus species to predict their future expansion to 2080 under various RCP scenarios. Scientists predict that climate change will have a more significant impact on future vector space than human migration patterns in the following decades. As a result, empirical models with several elements may help identify historical causes. Nonetheless, scenario-based models including various drivers may help predict future critical drivers. When developing excellent empirical models, it is essential to have data on the vector and animal host populations and non-climate causes, and meteorological characteristics. Creation of municipal and regional databases is badly needed. If critical historical components are lacking from scenario-based models, we may be able to identify them via empirical models. The effects of real-world and non-climate change situations must be also considered. To conclude, preventative measures include eliminating vectors, detecting and treating infections early on, immunizing the population, improving water and sewage system quality, reducing urban heat islands, and other methods of eradicating infection sources. Models that can predict vector-borne diseases outbreaks in the near term are being developed in early warning systems so that public health may take preventative actions before an epidemic occurs. As climate change continues to pose new threats to vector-borne disease management and prevention, including a wide variety of intervention scenarios, and scenario modeling may assist guide future efforts to improve the effectiveness of current approaches. Thank you for listening.